Okay、はい、それではお時間になりましたので、始めたいと思います。1日目からレガシー化になります。よろしくお願いします。
Okay, hello everyone. It's nice to see so many of you here. My name is Jakub Kozłowski. I'm a Scala developer at Scalac, and I'm from Poland. And today I'll be talking about how you can mess up your project from day one. The title says legacy code from day one because it's never too early to start messing up. Too early or too late. So before we begin, I want to make a few disclaimers. First of all, this will only be a handful of ideas for how to mess up your project. There are many more. You can research them for years, for maybe your whole lives, and still not discover all of them. But I'll try my best to give you the skills to mess up quickly. And of course, I don't want to offend anyone, either people who follow these practices or those who don't, because that's not the point. The point is to make you better at messing up. And so some of the examples that I'm going to show are going to be over-exaggerated because that'll show the point better, I think. And last but not least, even though it occurs in many examples, I really have nothing against MongoDB. It's a great database. It's just a victim of the ideas. So the plan for this talk, the agenda or schedule, if you want, is we'll go through 3 of the development phases. The code review phase, which happens, it's not a separate phase, of course, but it's an important step in the development of a project. And maybe not exactly development, because development is a separate thing, but it's a step in producing the software. Development is the second part. It will focus on the actual act of writing code and actually adding functionality, adding some tools. And then we'll go through maintenance, which will span into after we have released the project and need to add more stuff to it and keep it alive for a few years or more. So code review. Before we start talking about it, let me quickly recall what it is. So in the most basic terms, code review is the act of discussing a change of code before it ends up in the product, in the working version. So it may look like this. The author of a change can send a list of changes, some additions, some deletions to some files, or some binaries, whatever, to the people who review the changes. They might just publish it on GitHub or some other source repository for others to look at. So the reviewers then will go through each line of the change and say and think whether something could be improved. Like, can we be can we be faster in this line? Can we waste less resources, or do we actually need this line at all? Or are we gonna have bugs because of this line? So after they are done, they submit some comments back to the author, who then can they can make more changes to better fit the views of the reviewers and everyone else. They can discuss a change further if they don't agree straight away. But when they are done, they send the code back to the reviewers again to see if the changes are satisfying for them. And this cycle can go on a few times. So with some bigger changes or more controversial changes, it might be 5 times or 10 arbitrary numbers. And after everything is resolved and the change is ready, the reviewers agree that it's okay. They send an approval back to the author, and then the author or someone else who has the access for that, they can merge the change into the team repository, for example, the development branch. So that's how the code review works. So let's think about how we can do it, because there are many articles, even books, audiobooks, whatever, about how to do code review. So you might wonder how to do it best. So if we want to mess up a project, the best way to do code review would be not to do it at all. Why? Here are some reasons why you might not want to do code review. Your code is perfect. You've always written code, and you probably have looked at it and said, wow, this is some beautiful code. And you never went to your code and said, wow, this is horrible. I don't want to look at it. So why send it to someone else to blame you for it if it's perfect? You are always consistent with your formatting. Like you never add any spare spaces at ends of lines or before the parentheses and so on. Things that don't matter at all. But your naming convention and your style of coding is always consistent as well. You'll always name the variables the same way as the rest of the team without the team interfering. So you don't need to ask them how to name a function or a variable. And because you've seen how many cycles this can take, how much time this can last, if you ignore code review, you'll waste less time on the process, and you'll have more time, which will equal more code written and more features delivered, which is what we want. And last but not least, if you don't code review, nobody will feel judged, because you won't be blaming anyone for the code, and nobody will be blaming you for yours. Unless there's one condition in which you might actually want to do code review. It's if you are the one judging. Then you're free to go. You can ignore all these points here, and you can start doing the code review by blaming everyone. And you can invite all of the company because why not? So let's look at how we would do it. But first, the code review rule number 1, focus on the least important thing. That's the basic idea. So here are some comments. I'll go through them one by one. They were written by the whole company, basically. And each of them is about a specific trait of code, a quality of code. So the first one is from our sysadmin. Can you add a space before the parentheses? It looks cooler that way. So this comment is about flexible formatting. And as we all know, being flexible is important in all cases. As flexible as possible and even more. Here's another comment from a developer from the other team. For some reason, they care about our project. And they said, let's use Jackson for this. Implicits are too hard. Who cares that it's a Scala project? And this comment is about being technology agnostic, which means that you should use as many JSON libraries as possible in one place, which will in turn be technology agnostic spaghetti. Another comment from a finance manager who once wrote something. Can you add these 5 lines to save this 50 milliseconds of latency? I know that we only run this job twice a month, but we need to be super agile. And this comment asks us to optimize early. Because who knows, maybe at some point we'll start using this once per day or once per hour. Then we'll need those extra milliseconds and spare cycles. So if you want to end up with a lot of code that doesn't need to be there, and you really like writing more code, then you should definitely optimize early and maybe even prematurely. Because who knows, maybe in 5 years we'll use it. Another comment, this is almost the last one, and this time it's from an actual team member. Wow. Let's make this method public for potential reuse, although it never happens because we duplicate code a lot. So this comment is about optimizing for reusability, even if you don't practice it. So you should strive for reusability at all costs, even if you have a function that has 10 lines and you have to split it up into 3 separate functions, even if you just use them once in that function, because you need to be modular, you need to be composable, and you need to, yeah, this is functional programming. You need more functions, right? And the last but not least, the comment from the guy who always rejects refactors. So imagine you added some library that removes boilerplate, like shapeless. Maybe you added a library that uses shapeless underneath, and this guy says, "Can go back to our boilerplate." So this is a guy. So he wants to put simplicity first, and then boilerplate, because you should be as simple. Our code should be as simple as possible. So we're done with code review. I hope you learned some important lessons. Now the development phase. So we'll go through 4 ideas. These are just random ideas for development. So I'll start by saying how you can scale your teams, because that's definitely a problem you need to tackle at some point. I'll talk about the benefits of reinventing the wheel, ignoring the type system, and ignoring warnings. So it's a known fact of the universe that teams scale linearly. So the more developers you add to a project, the more features they will deliver. So on this graph, you can see that adding more developers made the amount of commits skyrocket, even though the scale is adjusted at the end. So in essence, you should grow the team until its velocity satisfies you, or you're out of money and producing no features at all, which would actually cause the project to mess up. And that's our goal. Now the second part, the reinventing the wheel. So I'll talk about a use case in which, at some point in basically every useful project, you'll need to integrate with some external service, like somebody's API, like GitHub's or Twitter's, or just a database, most likely, or a search engine, like Elasticsearch or something. So you need to make a choice. You need to decide whether you're going to use a library that's already existing in your language, because if you're using a fairly popular language and you need to integrate with a fairly popular tool, chances are there's already a library for that that's maintained. Then should you use it? I don't think so. Why? Because you may not like the creator. For example, they dress in a way you don't like or have a funny name. It might break compatibility at random points. For example, every year. Who wants to upgrade their code every year? Sorry? So a thing that's worse than breaking compatibility is no new features at all. So if it stops being maintained, you won't get any new functionality and you'll have to write it yourself. Or even worse, the code might be deleted, and then you won't even be able to expand on it on your own. We also have to think about the security of our code. So if you use an external library produced by someone else, it might contain some security holes, or somebody might steal the author's laptop and make some malicious changes to it. We don't want that to happen. And most importantly, we don't understand the code anyways, so why would we put it in our project? So here's the lifesaver. We'll just write the library on our own. And the benefits of that are we can write more code. Because we're developers, we love writing code and more code. We can focus on writing libraries instead of actual functionality, which would be boring. We can now fully control the release cycles, so we can release every month, every year, or every day, and that only depends on what we want. And we can store the artifacts, the jars, or the compiled version of the library where we want to, and we can manage that space on our own, even if it's an additional problem. And we also have an unlimited support, because every time we need some new functionality, or every time a new bug is discovered, we can fix it on our own and hit the same walls as the authors of the original library did. But that's not a problem, right? And this is very important. We can add any functionality we like, even if it's completely unrelated to the library and involves our business logic. Why not just put it in a library if we can control it? And at last, there are no compatibility issues, ever. If you want to make a breaking change, or a change that will make the previous deployed versions not work, you can just release it and update all the projects that are using it, because that's very simple. So we have a solution for that. Now another problem. Let's imagine we want to deserialize data coming from MongoDB. As I said, there would be MongoDB in the samples. So let's look at this example code. This is, we'll have a trait called Mongo value, which will represent the data inside the database. And we have a case class booking with 3 fields, so nothing really crazy. And we'll need some way to convert this Mongo value to a booking in the simplest way, so with just an option. We could just throw an exception, of course, but let's say we want to be monadic this time. So for the example, let's just assume that BSON, the underlying data format of Mongo, is exactly JSON, just to be simple enough. So Mongo value will have 4 types underneath. A Mongo object, which will be just like a map of strings and Mongo values. A Mongo array, which will be just a list of Mongo values, or just a string or a number underneath. So if you were to solve this problem, this conversion problem with type classes, you would most likely end up with something like this. A trait Mongo reader, so the name is whatever you want, but it'll have a type parameter t, and the function that's able to read to accept a Mongo value and return an option of t. So for long, the implementation would look maybe like this. So if we have a number, we'll just return the number. Otherwise, we'll just return none. And for our booking class, if we had all the instances provided for string, for booking ID, for zoned date time, we would be able to come up with such an implementation for Mongo reader of booking. And now our conversion method, our to booking, would be trivial. We could implicitly find a Mongo reader of booking and call read on it. So is this simple enough? No, it's not. It's too complicated. So here are some drawbacks of this solution, of type class based solution. It's a complex pattern based on rocket science. To understand type classes, you need to have a PhD or worse. And you need to understand something even harder, implicits. All the instances for the classes that you have need to be written by hand, which is boilerplate. Or even worse, generated. Who wants to have generated code or generated values inside their project? So I think we would rather have boilerplate, and that's what we're going to do. So let's change our values a bit. Now instead of a Mongo value, we'll have DB object, which underneath has a map of string to any ref. It has a companion object with an empty value, but let's just skip it for now. And our booking is no longer a case class. It's a plain old Scala object, which has a DB object field, and uses the methods on DB object to get or set values on it. So we had to add these 6 methods, but now we no longer have type classes, right? So it's clearer. And yes, we have a ID opt def that will return an option of string, and an ID method, which will never be called if the ID is not there, will it? So using option.get is definitely safer than nulls, as we'll see on the next slide. So now to save a booking like this, we would create a new booking with a new DB object. And now we have lenses for free. We don't need to use the copy method or any lens-based library. We can modify the fields in a very simple way. Just call .name equals hello world, or .time equals .time now. So now we can save our newly created booking to the repository. And then let's say we want to print the ID of the new booking. So maybe the repository actually updated the ID, maybe not. So in case it didn't, we'll have an exception here, but that's okay because we are adopting the let it crash behavior from Akka. So now we're also reactive. About ignoring warnings, here's a short snippet. We created type ls for a string called click, and we have a function. It's simplified here. It just compares the click and the string by value, and it works. It's fine. Until we decide to make a change. We want to make click more type safe, so we'll make it a value class instead of a type alias. And suddenly we'll start getting warnings. Comparing values of types click and string using equals will always yield false. But that's okay, until somebody notices. But the code compiles, right? We now have 0 errors and 94 warnings, and this is fine. I actually saw something like that running after this change for a few months, and nobody complained because it was fine. There were no errors. So we're done with development. Now we'll talk about maintenance. So here are some general rules that you should follow when your project is already running somewhere. You should never document anything. Like, if you have any business requirements, any technical choices, you should just leave it as an exercise to the reader, because, well, that's an interesting part. Why should you spoil all the fun? You should also release rarely. I'll talk about why in the next slides. You should customize by default, which I'll explain shortly. Couple tight and refactor in batch and never change. So let's go for them. About the documentation. So you should not document anything because the requirements will never change, and there's a chance that nobody will have to ever look at your code again. The team members also never change. Nobody ever leaves your company, right? Nobody new ever comes back. And you never have to explain everything from scratch. Tools also never change. You never want to migrate from one type of database to another one, because who would do that? So nobody will ever need to modify your code. About the releases, you should release rarely, like once a month or once every 2 months. This way you'll avoid bugs for now and delay them to later. You'll also need to invest not as much money into your deployment, because you'll be able to do the deployments manually. So no more CI infrastructure for you. And more money for development, right? And you won't have to stress out about a release every day or every hour, which will definitely help you get better sleep until you have to actually release. So another great way to mess up your project is customizing by default. For example, start your project by using a weird branching model. So just start by doing something you like most, And then when you have grown your team and you need to bring new people and explain to them why the release branch is the target of the PR from master or such weird things. You should also customize your deployment stack. Just use your own tools so that when you encounter bugs, you cannot easily search for them for like AWS bugs. Just find your own bugs. That's all the fun. If you ever had to write something big enough that it had customers who are paying for features, then you've probably written some customer-specific logic. So you should definitely keep it in the same code, in the same files, in the same classes as all the other functionality, so that you have everything in one place. That's the simplicity rule, right? Why would you ever split that out somewhere else? And you should have custom tools and wrappers for everything. And this is also kind of similar to the rule of reinventing the wheel. If you have your own tools, your own deployment stack, your own, maybe even your own database, you'll have more control over it. So now about the tight coupling. So tight coupling is definitely a good idea for messing up a project. So imagine you have a layered architecture in your project, then sometimes, or maybe all the time, it's a good idea to mix layers. For example, write some database queries in your service or your controller, or actually move all the business logic to your repository, which will directly access the database, because why not? You'll have all the code in the same file, so it'll be easier to move around, even if you have a million lines. And you should avoid abstraction of your utilities. So I mentioned that before. What's the chance that you will want to move from MySQL to Postgres, or the other way around? Nobody does that. Maybe small companies like Uber. And refactoring, I think that's one of the last points. So if someone asks you to do some refactoring during the development process, when they see something weird, something that needs to be refactored, just say, we'll fix it later, or this is how we do things here. And then at some point, hopefully in 2 years or 5 years, you'll just go through the whole project line by line and refactor everything, because that's how you should do refactoring, not at every sprint or every couple of months, just everything at once. And it should never change. So if someone comes up to you with a new idea, for solving a problem that you've always solved in a maybe a bit boilerplatey or maybe a bit overcomplicated way, then you should never allow them to do that, because then you'll have too many problems. You have one problem already, so why do you want a new one? So it reminds me of this comic. So if someone comes up with a creative thing, you should still strip away the unusual bits and make it fit the whole project, the whole mess that you've created with these rules. And at last, remember that it is not necessary to change. Survival is not mandatory. So you can just stick to your old rules and you'll be okay. But your project maybe won't. So here's a short summary. There are lots of ways to mess up. I encourage you to research and try all of them. Maybe find more and practice them every day. And here I start being serious again. So thank you for coming. And I hope you have some questions. Maybe something was not clear. So yeah, I'm listening. Any questions? Here's a question.
Hello,
Hi.
Thank you for what's probably the most entertaining talk about legacy code. Quick question. So this is mostly about, let's say, technical aspects of how people would approach legacy code. How do you interact with people that would behave that way in a team?
Can you repeat the last
How would you typically interact with people who have this kind of behavior or attitude towards?
You leave. No, but you need to. I think. Well, I wasn't really very successful at convincing people to go the other way, but it's best to find a problem that's the most visible, and maybe spend some of your own personal time trying to come up with a way, to show a difference of how good it can be if you spend a bit more time on it, and just try to find the business value for them to spend some resources on improvement.
Thank you.
I think that's the general rule. Any more questions? Okay, so I guess that's it. If you want to look at the slides for some reason later, they will be here. And if you want to get in touch with me to ask some question you were afraid to ask or anything, you can reach me on Twitter, on email, or you can find something else on my website. So thanks again, and enjoy the rest of the conference.